Welcome to Constellations, the podcast from Kratos, where leaders discuss what's coming next in satellites and space.
Welcome to Constellations, the podcast from Kratos. My name is John Gilroy, and I'll be your moderator today. Our guest today is Rebecca Cowen-Hirsch, Senior Vice President for Inmarsat. Rebecca, how are you?
I'm doing very well, John. Good morning. You
know, I did your research on you, got your background, and I've got 2 hours of background on you. Just give us maybe a half a minute on the mountaintops of your background, please.
All right. Well, I actually started my professional career with the United States Air Force as a electronics engineer, actually designing avionics system for integration into aircraft. And from there, that actually took me into the space arena, where I was a mission commander for the Advanced Ranged Instrumentation Aircraft, or ARIA, first ever female civilian mission commander, where we did telemetry collection for satellites, reentry vehicles, and cruise missiles. From there, a number of different positions, senior executive positions in the Department of Defense. And just a little over 9 years ago, I joined Inmarsat, where I've had the opportunity to work with some of the finest satellite communication capabilities in the world.
When I heard that, I wanted to run out of the room. Telemetry projections. Well, you don't want me doing that. You know, telemetry is kind of a word that most people understand, but there's very specific words involved in your world, and I want to throw a couple at you and maybe can tell you what they mean, what they don't mean. One word is called assured communications. Mm-hmm. So what does this mean to you, and what does this mean to your industry, really?
So assured communication really picks up on the meaning of reliability, availability, and knowing that you can get your information from point A to point B in a fashion that is secure. It can't be intercepted. It can't be degraded. But importantly, when, in our case, supporting the United States military, allied military, and other defense and federal users, knowing for certain that you have satellite communications anywhere you go, so that you can plug in, operate, and know that your communication can get where it needs to be, whether it's voice, video, or data.
And also there has to be some resiliency built in as well, I assume.
Resiliency is incredibly important. It's the really paramount to everything that Inmarsat does. And today in the defense industry, especially in the satellite communication, satellite arena, resiliency covers a range of different attributes, from redundancy, reliability, distribution of capabilities. And it's all about making sure that whether it's a threat environment or just an interference environment, communication and the mission can be accomplished. And from an Inmarsat perspective, we look at it as having the highest availability of any satellite communication capability available today. For safety services, so that you can ensure that it's your safety services for aeronautical operations, or for ships at sea, that you have what we call 4 nines of availability. You know for certain that you're going to have a redundant, fully capable safety service as well as mission-critical data, and relying on that satellite communications for all of your missions.
Rebecca, I mentioned the parking lot on the way in here, and we're talking about all these new things going on in the world of satellites and space, and so many different new terms and everything else. And one concept that people are talking about is something called a wideband global satellite, or what you may call WGS. Where does it fit in with this whole picture of resiliency?
Well, so the wideband global SATCOM system is kind of the workhorse for the military satellite communication capability today. It's a program that started as a gap filler program some 20 years ago to be able to provide that communication for military operations. And it operates in 2 separate frequency bands, and it is around the world to be able to support military wideband communications. And of course, the challenge that's facing the military is recapitalizing their existing and legacy capability. And this is very true for not only wideband global SATCOM, but also their narrowband communication and their protected communication. So it's a part of a military architecture today where the government owns and operates exclusively their own satellite systems. In the recapitalization effort, what is being looked at quite intentionally for the first time is ensuring that commercial capabilities, which has been providing the preponderance of military traffic for a generation now, are intentionally embedded into this architecture and planned up front rather than what has traditionally been ad hoc purchasing of spectrum or filling in the gaps, if you will. So what we're looking towards the future is this integrated SATCOM architecture where commercial is the foundation, augmented with the legacy capability of wideband global SATCOM, and then filled in with a small purpose-built amount of capability to address the most specific, unique military specified missions for which there is not a commercial model or for which new R&D needs to be accomplished.
When we get in a car and drive down to the Pentagon here, they use this term visibility. So focus on terms here. And so my question is, how can the commercial sector provide this visibility into the commercial satellite network that the military folks really need to assure their mission?
Well, one of the new considerations, if you will, is looking at satellite communications more as a network. We've traditionally focused on the satellite, and that's certainly true within the United States Air Force and its Space and Missile Systems Center, where they acquire satellites. With satellite communications, the satellite is just one node on the network, if you will. To have the full communication capability, it's the satellite, it's the ground network, and it's also the user terminals. And so if you look at that more in a telecommunications environment, that's a network. The satellite is just one other node on the network. So when you look at a full end-to-end capability of this network of telecommunications supplied by satellites, having visibility into that to be able to see what your network management principles are, your availability, any interference you may be experiencing, the ability to reprioritize where necessary is readily available in today's environment. And many of our mission partners, to include the host for this particular podcast, Kratos, excel in that network management, the visibility, and the assurity of access for satellite communications.
I was at a trade conference with a bunch of people focusing on data centers, and most of the room was filled with govies, and they were interested in what the commercial world was doing to improve the federal government's use of data centers. And the parallel's got to be with the satellite world as well, too. So is there anything the military can be doing now to take advantage of technology already under development in this commercial sector?
There are a couple of different areas specifically that they can focus on. As I mentioned earlier, using commercial as the foundation. Commercial satellite communications has provided the preponderance of capability for military and defense operations for a generation. But it's been acquired on kind of an ad hoc, spot market type environment. Well, so if you shift that paradigm, put that foundation of commercial SATCOM in first, intentionally and strategically put redundant and resilient satellite communications provided by commercial in place, then that's a very different mindset. It's not only a philosophical shift, but it's also an acquisition shift. So then you can actually bring greater value to bear, greater capability, distribution of capability, redundancy, other elements of resiliency to the network, allowing the military then to focus their exquisite talents on what is traditionally called warfighting missions. So leverage the commercial, not only what we provide today, but importantly, the new technological advances that are coming into the environment on a very rapid basis to be infused into this network to bring the best to bear. So it's very responsive to what military operations require for worldwide communications on the move. What
you're saying is this technical capability is almost a checkbox item we have to take in and maybe overcome some of these cultural impediments. In fact, you talked about this in some quotes, and you said that building additional wideband global satellites would be pressing the easy button for this transition. I want to go to the Office Depot or Staples to get one of those easy buttons.
Absolutely. If you look at, and wideband global SATCOM is a fantastic satellite communication capability. As I mentioned, it's a program that was started quite some time ago as a gap filler. It's in its final stages of deployment. 9 satellites are on orbit. The 10th is scheduled to go up next year. But it's also this very mature technology, and the same company and the same production line that builds wideband global SATCOM is the same production line, the same value chain that builds the commercial satellites, to include Inmarsats. So in the meantime, during this period of from concept to now deployment of a military satellite communication capability, satellite communication industry has evolved orders of magnitude in terms of different generations, improvements on technology, agility and responsiveness. And so communication is now a worldwide managed service environment that you can plug into, and I think the government will be is today quite well served by the capabilities provided, and there's more exciting things that are coming in the future.
You know, Rebecca, you've got a background in electrical engineering, and so when you toss out a phrase like order of magnitude, it means something very precise for you. For someone like me, big changes and wide differences, and so I'm trying to apply this to high-throughput satellites. So is HTS a high-throughput satellite? Is this an order of magnitude change, or is this just a bump?
It is an order of magnitude change. It's not only technically more advanced and more capable, but it's also a different architectural implementation. So the military has traditionally used satellite communication systems that are designed more for television broadcast. And so when you bring in, certainly as our architecture, a high-throughput system, you have smaller spot beams that makes for greater resiliency and anti-jam resistance, but it also actually, the way the system is designed, enables organically mobility operations so that you can actually traverse from small spot beam to small spot beam without having any degradation of capability. So if you take off in Omaha, Nebraska and land in Paris, France, as an example, you actually will be able to go from spot beam to spot beam seamlessly to be able to have connectivity and access to information that entire traverse in that route of flight. And that certainly is relevant in military applications as well as in our commercial applications and what we as citizens enjoy. So it's, it provides enhanced technological capability, but also greater mobility and greater implementation.
I was kind of trolling through your website, and I'm wondering if some of the words I saw on your website maybe fit in with HTS. You talk about cost-effective augmentation. Is that tied in directly with HTS, or is that a different concept?
They are tied together. Certainly the way that we design our high-throughput satellites in our Global Express constellation is designed with affordability in mind. So that means not only is the service provided very affordably with great attributes such as reliability, availability, trusted, and secure, but since it is designed with a fully redundant ground segment that is a smaller footprint. So each of our satellites have two fully redundant satellite access stations. The ground infrastructure is affordably deployed. The satellites are designed for flexibility as well as mobility. This allows you to actually have this consistent, ubiquitous capability wherever you operate, and designed with a cost factor in mind so that you actually can not only have that value proposition of availability and reliability, but at an affordable rate. And when you put that in from a taxpayer perspective, that actually says you can actually have the capabilities to have the throughput and prosecute the mission, whether it be a command and control capability or advanced airborne intelligence, surveillance, reconnaissance, telemedicine. Also, of course, cybernet cafes. You want to take care of those troops as they're deployed to ensure that they can have the ability to reach back to their family, and you do it in a manner that's affordable but also highly reliable and secure.
I'll be teaching in January, and I always assign my students Harvard business test cases to read. They can read those, and they come in class and we talk about them. And, in the software world, they talk about use cases. So if it bounce back to the wideband global satellite, give me an idea what a use case might be for wideband global satellites. Is there something that's obvious?
So the wideband global SATCOM system was originally designed to support predominantly the Army, so troops on the ground as well as other military applications. Of course, subsequent to its original design, and there have been some enhancements to that, there have been new capabilities that have come online that were not even envisioned as long as 15 years ago, and that's the advent of airborne intelligence, surveillance, and reconnaissance, the very high throughput and data intensive applications that require greater throughput and greater flexibility and greater mobility. And this is really where our systems come in as a fantastic complement to wideband global SATCOM, so that you can actually have wideband global SATCOM, where with its beams fixed to support certain different type of mission sets, bring on top of that interoperable and complementary commercial capability immediately adjacent in frequency band as well as location, to be able to add that more flexible and adaptive SATCOM as a service to overlay and integrate into the military environment, offering not only two different or diverse satellite communication paths, but also with our steerable beams, the flexibility to follow airborne traffic, put additional throughput when and where required. So the complementing capabilities that we bring and the commercial industry provides actually enhances the flexibility of military operations.
SATCOM as a service. This is, again, falls back to this cultural change, and cultural change goes back to acquisition. And there's certain types of procurement practices with the federal government now that are just, this is the way we've always done it. And now technology has come about with innovations from your company. They're saying, no, this is a whole new way to do it, and gives you more flexibility, more redundancy, more resiliency, and the whole checklist. But we have this cultural procurement challenge here, don't we?
There are some disconnects. One of the opportunities that SATCOM as a service provides is really it stitches together the satellite into a communication capability. And by that, I mean, with communications via satellite, it's satellite, ground segment, as well as user terminals, and the fiber connectivity that makes that an interconnected environment. It is the full end-to-end. So when we use the term SATCOM as a service, it means that you're actually getting a capability, not just buying a satellite and then having to stitch together elements to create a communication path. So SATCOM as a service allows military or commercial users to be able to, if you will, plug in and enjoy the service, the complexities of the network management, the ownership of the satellite, the maintenance on the ground stations, the technology insertion, all are done by the owner-operator, making sure that it is the best of breed at all times. The consumer, in this case the military, benefits from that investment. So rather than focusing just on the space segment alone, it is the full capability and the technology insertion and all of the other measures of effectiveness that make communication a capability and not just a commodity are enabled through SATCOM as a service. The corollary to this would be very similar to your cell phone. So the network behind your whichever device you prefer, whether it's an Apple product or a Google product or anything else between, the network behind that, the cellular infrastructure, the towers, all of that is provided as a service. You're not concerned so much about owning a part of that tower or worrying about a piece of fiber that connects it. You just really want to turn your phone on and use your application. SATCOM as a service does that for the military, so that the applications are available when and where needed. You can plug in. It's available when you need it, and you can actually benefit from advancements. And that includes when you renew your service and you want a new or different terminal that's more capable or incorporates new technology, that also can be embedded as part of the service. So while it's not new in the telecommunications industry, the acquisition process today in the Department of Defense for commercial SATCOM tends to be spot market, is also really more buying of spectrum or a piece of fiber, if you will, rather than the actual service. When you do SATCOM as a service, you have a service level agreement, a commitment of availability, guaranteed committed information rates, so other things that make it a capability rather than just leasing spectrum. New opportunities for improvement, and also to do it in a value proposition so you get performance-based capabilities rather than driving down cost in a LPTA or a least price technically acceptable methodism, which is used predominantly today.
Well, I want to take the satellite discussion and bring it down to ground level. I have a son whose friend's in Special Service, Special Forces. Mm-hmm. And last time we spoke, we talked about this any place, any time thing. And he talked about new initiatives involved in any place, any time, really letting the military with feet on the ground be able to communicate through satellites. It's really, some of the innovations here are just impressive, aren't they?
Very much so, and there's no one more impressive than the special ops community. They just innovate in a way to be able to get that job done so quickly. And we've been working with the special operations community to ensure that they have access to the most advanced technologies, but also they are very agile in the way they deploy, and they want to be able to have very small form factors and very light equipment. And so the terminals that they carry, the user equipment that they carry with them, needs to scale for their applications. And so we have, with them and with some very interesting technology advancements in antenna technology as well as air interface technology, reduce the size of the terminals that they carry while continuing to increase the amount of throughput or data or information that's available to them. And that's not just the soldier on the ground, but also the very small form factor of aircraft, whether it's manned or unmanned, so that they can use a capability that we've developed in partnership is what we call WHISTLE, which is wideband streaming on L-band, which allows an airborne or ground-based to have very high throughput and a very small form factor. So up to 10 megabits per second streaming bidirectionally to a form factor for an aircraft that is somewhere on the order of about 8 to 11 inches. Very small form factor allows them to be connected in the most austere environments with the most unique and small and highly deployable assets, and yet use these phenomenal satellite communication capabilities globally.
And that's one of the purposes of the podcast here at Kratos, is just let the community know about, look, there's so much new stuff out there, you can't keep track of it. Maybe we'll have Rebecca next week and do what's late this week. There's so much coming out there. Small sizes of antennas. Mm-hmm. You would think that, it's kind of much more impact than just reduction in cost. I mean, it makes them more portable, don't they?
It does. There is many aspects of a military operation that are critical that need to be addressed, not just price. And I don't mean to imply that cost is not a factor. It is an important aspect. However, it really is being able to execute the mission. So it needs to be reliable. It needs to be present. It needs to be capable. It needs to be small form factor, and it needs to support the mission where it lives.
In the NFL, they always say, well, the team coming up on Sunday, they have good defense, good offense, good special teams, good something or other. So different areas of concern. So if you looked at the next 4 or 5 years as far as applying newer technology and helping our government listeners here, what are the 2 or 3 areas you'd think are the biggest challenges?
Certainly power management is always a challenge. And you need to be able to have this disconnected user, so somebody that's not going to plug into the wall, be able to ensure that they have power to support their antennas. There's a lot of solar technology that's being invested to be able to power that. So this is very exciting. So you're not dragging a case full of batteries along with you. On the satellite side, the spot beams are getting smaller, the flexibility to be able to respond to the environment and support the user. This has certainly came in with what we're now calling HTS systems, or high throughput satellite systems, and the agility to be able to steer and beamform, to be able to be more flexible to support the users. There's quite an enamorment today in what is often referred to as new space technologies. I think what will come from that adventure is capabilities in space to support imagery and other elements, as well as some advancements perhaps in communication that can then be deployed into the blue chip companies such as Inmarsat and others, to be able to continue to evolve the technology to stay long ahead of the curve. And we certainly invest in advance of need and insert technology to make sure that we can capitalize on the satellite asset, which is on orbit for a minimum of 15 years, in some cases well over 20, to be able to capitalize on that asset and innovate on the ground to be able to get the best out of that space segment.
Whether that's looking at new antenna technology, new battery technology, or technology comparing building versus leasing transponders. I mean, there's so many aspects to this besides the technical element. I think that's the lesson, I think, from the interview today, is that, wow, we got the technology, now we have to take and integrate it into a system and take and apply it to the special forces person who's going to jump out of an airplane somewhere, who knows where, carrying what. I mean, batteries are a big important part of their life, aren't they?
Certainly. And the business relationship that exists between the industry supporting the national security enterprise. The government is looking at an analysis of alternatives right now to recapitalize their wideband communications systems, and they're engaging very fruitfully with the commercial industry to look at new business models, the technologies, the advancements that are available so that the government can focus their energies and their investment on the most exquisite capabilities, but intentionally leveraging commercial in a very different fashion to be able to respond to these very dynamic and changing environments.
Yeah, leveraging commercial to help our listeners. We like that a lot. Rebecca, unfortunately, we are running out of time. I'd like to thank our guest, Rebecca Cowen-Hirsch, Senior Vice President for Inmarsat.
Thanks for listening to Constellations, the podcast from Kratos. If you like this interview, please subscribe, tell a friend, and give us a review.